Welcome back, dear friends, to another exciting episode of how to add the amazing programmable LEDs to a Dinosaur time machine. Sadly for this next bit I'm going to have to turn all the lights out and shut the curtains. Because I found that the camera will not pick up, especially the red ones, if you've got any other light. So as I turn this, there, you can see they all come over. That's lovely. So it's time to assemble things. Also, the other great thing about assembling it is trying to see what this is actually going to look like, the effect it'll have with brightness and things once those diffusers are on. Let me show you. Here's this next bit, which I've peeled the masking tape off. That's fitting nicely, so that leaves that gap, clearance gap. Then we have this bit, which will be there. And if you remember, I decided not to paint that bit because I thought it'd be quite nice to have a little black detail around the outside. That's a 2mm gap, and then this final part that goes on top has got a 1mm gap. Oh look, isn't it lovely the way it all fits together? It's such a joy. I think that looked lovely with that little... What a fool I've been. I try and avoid saying that too early on in a video, but what a fool I've been. Look! So I've got these 20mm countersunk brass screws, M3 screws, and countersunk them enough to make sure they were flush at the top, and they just push through beautifully, and all the holes line up, which is great, and they reach through. So what I'm going to do is to drill a little hole in the back of these three, big enough for M3 nuts, so they don't protrude too far. But that's lovely because that's now fixed down, and the plan is to glue that down with lining it up with the screws, and then to glue this on the top, lining this up with the 4 M4 screws, one in each corner. That's right, and they too line up, which is great, except that one. So what I need to do is put all the other ones in and just run the M4 drill through that hole through the wood. Well, that went okay. I didn't film it because whenever I film it everything goes horribly wrong. What, you want to see me screw it up? Oh, how kind, how lovely. Right then, I'm going to put a little bit round these because they don't matter, and I'm just going to keep well away. Can you actually see any of this? Oh yeah, I wasn't looking. Look at that. Okay. Well, I think that's set now, sufficient at least to hold itself together, so I can lift that out. There are the 4 captive M3 screws. Now I can drill those holes out for the M3 nuts. That's right, lovely. And in fact, I think I'm going to do the same with M4, because I'll use nice long bolts that Ben can have plenty extra to stick through the base. But I don't, it'll be a bit of a pain if when he unscrews them or doesn't have any bolts on and then this is loose and things. So I think, I'll do that as well. That's better. Perfect. And the little socket just reaches down the side. So I've tightened them. I've also drilled out little rebates for the M4 nuts, which are fine because they'll remain tightenable from the front, so that I can get on working on the sketch. I want to get that done. That's the whole purpose of this. Right, this is exciting because I can now peel off the protective film, hoping that I haven't stuck it in place. Yes. Lovely, look at that. Other than some sort of blemish there and there somewhere. Oh, what a pain. Right, I'll try water first before I resort to harsh chemicals. Sadly, water didn't touch it, but I've just tried some isopropyl alcohol on that scrap bit and rubbed really hard for ages, and it didn't touch it either. So that's brilliant. I'll try isopropyl alcohol. That seems to usually get rid of everything. Thank goodness for that. How ridiculous. You wouldn't credit it. I've been so careful. Somehow the protective film must have lifted in storage or something. Something got underneath. Right, finally, after all that, I'll get that connected back up and then recap where we're going and what we're doing and stuff like that. What we've got so far, and that does look really nice. Hopefully you can see that with the lights turned down low. They go across. I can then keep turning this because that's where the other, I think it's 3 effects are going to go. You want them to go across. As you keep turning it, little flickery white lights increasingly coming on until it's all white. Then keep turning it, they all whoosh across to that side, keep turning it, and then they go round and round and round. As this is going to be a very long, slow and tedious process, I suspect, call me old-fashioned, I think what I'm going to do is I'm going to get it done, hopefully, then I will finish this video, and after the end I will put a detailed explanation of how the software hopefully works, so that if you're of such a mind to be interested in these things, you can watch it. If not, you won't have to be inflicted with it. So hopefully I will see you before too many days' time. It's sort of several days later, still got the same shirt on, wonders of continuity. Right, let me show you what I have managed to achieve. So, it starts turning. So as before, the lights go across. Once they've all reached the far side, if you keep turning, you get little white ones. Getting more and more, randomly. Once you've got a screen full of white ones, they all go over and they start rotating. And these start fading up and down. Ooh, it doesn't get much better than that. Like I say, this has been so exciting learning how to do all this. And then if you turn it back, because of the way it's written, wherever it's switched on, wherever the position is, it doesn't matter. It'll just resume where you left off, where the position of the potentiometer. I'm so pleased with that. It's another frustrating day at the office, dear. I tell you, let me show you what I've been doing. The first thing I've been doing is to find that I had forgotten to charge the battery on the camera, so it was completely flat. Second thing I've done is finally basically sort of stained that, so that's nice, lovely, and screwed that down. I've got the little M3 screws that are level, and I have crushed an M4 nut into each hole, and you can't beat a crushed nut. And then added one for Ben to use to fix the back on. So that's nice. And I was thinking, why have an Arduino, big old Arduino Uno, which I only need one analog input and one digital output. And it might be possible that Ben at some stage could connect some of the bits and pieces, but initially that's it. So I thought, I know, just rummaged through my drawers and found an Arduino Nano. Fantastic, it's been sitting around for a while. Brand new though. I remember I was thinking about, the reason the orange light's flashing on and off is I was thinking about using it for that standalone barometric pressure gauge that I made recently, and then decided to go for a trinket which had even less inputs and outputs. But it is available, and I can't use a trinket because this software for controlling all these LEDs is too long to fit on a trinket, so we can use this anyway, and it's small and it can sit right in the middle. So I dutifully plugged it into my lovely laptop, and of course it wasn't recognised. I can't connect this online obviously because Microsoft in its wisdom decided to make it obsolete and stop supporting security features. So I've managed to finally install the extra board manager that you need for one of these Nanos, which is a Nano Every. Who knew there was even such a thing? So now what I'm going to do, which is most exciting, is to connect that back up to all this, having taken it into the kitchen to see whether it did work, and then try and download or upload the sketch to control all the LEDs onto that, and we see whether it works. This is another great thing about Arduinos, the whole system, is that you can change whatever board it is. Same sketch, you can decide what sort of board you've got connected. Just click on it and it will put it together, compile it for that particular board and its nuances, and then upload it. And it's just done that, and it hasn't come up with that many error messages. So, let's see what happens. That's now connected to this. The power supply is on. I will turn my knob. Ooh! Look! Oh, how exciting. Yeah, we've got the flickery dickeries. They're going to shoot a... Oh, this is brilliant. Yes. Oh, that's incredible. That's absolutely brilliant. Oh, it's been worth pursuing for all these hours rather than just using the thing I thought I was going to use. I've used something else. But it's all about learning. And I've learned so much this morning. Now, I was thinking whilst walking the dog yesterday, I wasn't really happy with the rotating LEDs, the time travel ones. They're too fast, you can't really see what they're doing. Let me show you. Not sure about that. So I'm thinking I'm going to rewrite that particular part of it, the function, so that you have the leading LED that's white, and then possibly in turn these ones fading dimly behind it, sort of following it round. I mean, this is fine, but why not? After some fiddling and farting, whiz them all across. Look, I'm really pleased with that, and it responds to the position of the potentiometer. I think that looks really nice because you've got the white and you've got the colour, and you can actually sort of see it going round because they're fading up and down, sort of. I'll explain it in the boring bit right at the end. Anyway, next step is to get that mounted on that. And it's very handy because the screw heads, the bolt heads on the front mean that I can sit this down and not scratch the paint, and the M4 bolts mean that I can sit it on its back, and when that's fixed on. Thing is, people ask me, why do you like Unos? Why not use smaller things? The reason is purely practical. They're not right in my mind. You shouldn't be able to do so much stuff with such small little things. But also connecting it. You know, with the Arduino you can get header pins, plug them in and connect wires to them. Whereas with things this small, nothing I've got will fit through the screw holes. Nothing at all. And I'm going to have to mount this now on some variable board, I think, and then fix that down. You know, it's just a little bit more faff, but that's one of the reasons that I like bigger things. So to mount the Arduino Nano, that's it, I've just used one of these to cut a little row of holes in this variable board strip, prototyping strip, whatever it's called. I'm going to solder it on that up so I can easily, if I glue this down, I can then just solder and unsolder wires as required. And there we have it, mounted nicely. Nice big capacitor that was recommended next to it. And yeah, we turn it over. Very pleased with that. Turn the knob, and it works a treat. Keep turning it. Whoosh! Brilliant. So pleased with that. It's so nice when you've got a plan and you actually manage to bring it to reality. Stay on the line if you want to see how the software works. Otherwise, thanks very much for watching. Hope to see you next time for the next instalment. Here we go with the explanation. Right, let's get on with it. I'm not going to rush this time. Normally when I'm explaining these things, I'm racing through it thinking that people are very quickly going to get bored and switch off. If you do, that's fine. If not, let's proceed. So at the top of the sketch, we're going to include the Adafruit NeoPixel library that tells the strip how to work. We're going to define 3 constants. The output pin from the Arduino where the signal comes out for the strip, the number of LEDs, 47, and the brightness which you want, which is about 50, looked about right. Then we're going to create an instance of this NeoPixel thing, object. We're going to call it strip. I think you could call it anything. We're going to say, okay, there's 47 LEDs from there. The output pin is pin 4, and these are the references for the special instructions basically that work with this particular strip. There are all sorts of other ones as well, but handily they worked. Then we're going to set up some global integers, which should probably also have been constants. We're going to tell it where each of the effects starts and stops. The first effect, the colour sweep thing, starts at 0 and stops at 519. The next one, which is the flickering, starting the white flickering, we want to start it at 560. Oh, by the way, these are the inputs. The input read from the potentiometer, the analog input read, which goes from 0 to 123. So we've got 123 to play with. I've left a gap between the end of the colour moving and the beginning of the flickering, because it was just nice to have the colours sweeping across and then a bit of a space where they're all over there, then the flickering. That goes on, but to the flickering starts 560, stops 900. Then the sweeping, when all the white sweeps, I'll use my hand, sweeps across the screen, starts at 901 and goes to 1000. And then the rotating bit, where the thing at the end is rotating minimum 1001 till 1024. So you know it doesn't jam. Give it a little bit of leeway as the kids turn it. And then there's other bits and pieces to do with the functions need. Then there's the setup that all you always get with an Arduino. It runs once when it first starts up. We've said there's the strip, the object that we set up earlier, created, the NeoPixel strip object thing. We're going to say begin, get it doing stuff, then show, which basically will write any data in it to the LED strip, but there's no data, so it'll basically just switch all the LEDs off, and then set brightness to the brightness we set earlier in the constant. Now this is the bit that the interesting bit. This is the loop that goes round and round and round. It stops there, so it just whizzes round and round forever as long as the Arduino's on, carrying out whatever instructions you've put between those two brackets. First thing, it's just going to set an integer called pot to the value of the potentiometer. So every time it goes around, it rereads the potentiometer. Then, and this was interesting, I tried all sorts of other things, methods to get this to work, but it turned out that having a series of if statements that just read the value of the potentiometer and just call each of the 4 different effects as and when it's needed. Originally I tried to write it all combined. Not a good idea. Keep it simple, stupid. So if pot is less or equal to colour max, which was the first one here, that's the 519, it says, okay, call this function colour wipe, send it the potential value and the colour max, that point where it's going to finish. So it needs to sort of scale down the current potentiometer reading to go between 0 and 13. That's what that does. Why I didn't use the map function. Anyway, so saves you having to muck about. And it does that for the purple and the blue and the green. Those were the colours that Ben wanted. Then, again, this just was the simplest way to do it. It creates 4 arrays, one for each colour strip, with the actual number of the LEDs in that part. So you can see it goes from 0 for the green strip over to 7, then 8 over to etc, etc. So you say it was halfway across. These would then calculate it to point to the correct number in the array. Then, and this is the last bit of this function, for each of the colours, this one's got 13 obviously because it's the red. It's going to go over while it's going to count up while I is smaller than that limit. That's the value, the scaled down value of the potentiometer. So that means it's just going to colour in, set all of the LEDs up to that point to be red, and anything over else to be nothing, to be off. And it does the same for the purple and the blue and the green. And that's it. And that's called over and over again while the potentiometer value is below that first effect, the maximum value. Then It says else if potentiometer is greater than that, basically, and smaller than the flicker maximum, so it's between flicker minimum value and flicker maximum value, call the random flicker function. And here it is, and it takes just the value of the potentiometer. It has a for loop that can account from 0 up to 42, representing all of the first 42 LEDs in those 4 colour strips. It's going to, oh how ironic, I didn't notice, I have used the map command, that would have made life so much easier. This takes the potentiometer value and scales it down to between 0 and 20. Oh, the map command is so simple. What? Oh, never mind, I won't say it. Basically, I did experience with this. Then you've got this integer, the rand white, I think it was standing for. It's a good idea to call things sensible names, which is a random number between 0 and 20. And then if the map pot, so that's the scaled down value of the potentiometer, is greater or equal to the random value that's just been created between 0 and 20, then you write that particular LED, I, because that's where we're going, and we're going round and round and round. So it means that this particular LED is going to be a random brightness. It's going to be white, but random between 10, so it's not actually off, and 255. Because I just found that having different brightnesses look nice. If it isn't greater than that random number, then it's just going to, if it's less than 7, it's going to recolour it the purple or red, whatever else, if it's smaller than 17. Basically, it just, if it's not white, it's going to colour it the same colour as before, recolour it. Then it delays 100 millisecond, 0.1 of a second, because that looked right, it just slows it all down. And then it goes back to the loop, which we'll call this again, so it just goes round and round and round, creating more and more, or less and less, white flickering lights. Back to the loop, so if we carry on turning it, it's then going to enter this one. Also, if potentiometer is greater or equal to sweep min, this is where all the whites are going to sweep, and potentiometer is smaller than sweep max, white sweep function, where it gets sent the potentiometer value, the sweep min and the sweep max values. Here's the white sweep. Very, very similar indeed, I think you'll agree, to the colour wipe, whatever it's called. First thing, scale down the potentiometer, duh, but the other way round, which took me ages to work. Same for arrays, telling it where the position or the number of each LED. I did try and make these global, but for some reason LEDs were flashing on and off all over the place, so I didn't do that. And then basically, to allow for the fact you might have turned it back down from the spinning LED effects, they've got a slightly different timing. If you don't address an LED specifically, it won't change, which is very handy. But in this case, I needed to make sure that when you start turning it back down, they'll be white, so they'll sort of rotating. They might stop rotating, but you'll still see them, they'll still be on. So that just basically switches those 4 LEDs off. And then as before, it goes through exactly the same as the colour white, but basically moving white across and leaving the original colour as it whizzes across. So let's look at the last function. This is the rotate effect, I've called it, and it takes 2 arguments, the pot value from the potentiometer and the rot min value, which is the minimum value of the potentiometer to start the final effect. If you remember back here, the rot min we've set to 981, so it starts towards the end. Lovely, right. Now the rotate effect is slightly different from the other effects because it's got to do 2 things at once. It's got to rotate the LEDs on the end, and it's got to fade up and down the 4 rows of LEDs. So we can't use delay. We're actually going to use timing a different way to achieve it, using millis. When you first switch an Arduino on, it starts counting the milliseconds, and it's got a huge number inside it that you can read by referring to the millis function. and it's so big that after about 4 months it'll run out of room and reset to 0. And there are right ways and wrong ways of using millis for timing, and I know this is the wrong way because loads of people have tried to help me, and I understand what they've said as soon as I read it, and then I just can't get my head around it. But this works for me, and I know, other than travelling for hundreds of millions of light years or years, the Dinosaur machine isn't going to be on for that long, so it's not going to be an issue. So what we do is we create a global variable called fade millis. It's an unsigned long, and it's there. So unsigned long fade millis, and while we're up, unsigned long rot millis. There's 2 timers, and we're going to set them both to 0. Unsigned long is the longest format of number you can have on the Arduino, as I say. So each time the rotate effect is called from the loop, it's going to come round and it's going to see whether the number stored in the fade millis is smaller than the current time, in effect. Now we started it with 0, so it's definitely going to be. So it's going to say, okay, it's smaller, let's do whatever's in these brackets. So what it does, first thing, it adds the next time delay onto our value. So fade millis equals millis, current time, plus 30, because I want it to next do it in 30 milliseconds time. Then it says if direction fade, again another global variable, is 0, then current fade equals current fade minus 5. So again, current fade is another global variable because we don't want it to forget the value between every time it visits the function. So direction fade equals 0 means it's going down, it's fading. Current fade minus 5. If current fade is smaller or equal to 20, because I didn't want it to switch right off, fade right out, current fade equals 20, direction fade equals 1. So basically it stops at the bottom and then changes direction. So if it comes through here next time, direction fade equals 0, no it's not. So else, current fade equals current fade plus 5, so it's going to fade up. If current fade is greater or equal to 127, because I wanted it to go to about half brightness, current fade equals 127, not quite sure why I did that, but you know, that's fine. Direction fade equals 0, so it changes the direction. So there we are, we're fading up, round and round and round and round till it's halfway full on, then they're going to go the other way or vice versa, you get the idea. So that is the first bit. Once it's gone through there and faded up or down the LED strips, it'll finish the rest of everything else, go back to the loop, do anything else required, come round. Has 30 milliseconds elapsed? No, okay, ignore it. Go round and round and round until 30 milliseconds or more has elapsed, then it'll do that again. So that fades it up and down. And then basically uses the value in current fade to run through all 4 strips, changing all the colours, setting all the colours to the right one and the current fade brightness value. And that was just easily done by having a 4 loop, goes round and round and round 42 times. As it goes between, it starts off there, if it's less or equal to 7, so that's the green strip, it just changes them all to green at the right brightness. And then if it's under 17, so it's done that one, then it does, etc, etc, you get the drift. So that's fading them up and down. Now rotating them, I've tried different things with this. Here's the other millis timer. So this is rot millis, very strange. Exactly the same principle, except, dear friends, this time we're going to base the timing on the value of the potentiometer. And this time I've remembered to use the map command, a new integer time add. And it's going to map the value of the potentiometer to the minimum of this, the function, the values of the potentiometer where this runs, and the maximum, which is 123. And we're going to map that to a value between 200 milliseconds and 50 milliseconds, the other way around. What it basically means is when the potentiometer first reaches the point at which this function operates, it'll rotate every 200 milliseconds, so it'll be slower. And as you keep rotating the potentiometer, it'll speed up until it's only a 50 millisecond delay. Again, through experimentation, it just looked right and the things spin around nice and fast. After it's set that, it's then going to go rotate millis equals millis plus time add. So this is where, unlike before, we just added 50, I think it was, or 30. Now it's going to add that value, which varies. And again, it only does that once it's visiting this, once the time has elapsed that we previously set. So you're going to ignore all this until the time has elapsed, between 250 milliseconds. I hope that makes sense. Then we're going to, rot-pos is another global variable. We're going to add one to that. Plus plus just means add one to that. If rot-pos equals 47, then rot-pos equals 40. So that just keeps it cycling round and round and round. 43, 44, 45, 46, 43, 44, 45, 46, etc, etc. Once he's got that number, I just felt this was the simplest way of doing it. I couldn't get my head around any other way. If it's position 43, then set 43, 44, 45, 46 LED up to these colours. And I tried different things. It just looked nice, with bright whites being the major one that changes through it. You can see it's the top there, then that one, then that one, and then the bottom, the next one. And then to have the other following that, red, green and blue at lower brightnesses. I don't think I've got that right, actually. Never mind. So yeah, it does look right. I think I'm going to have to go back and correct that. Oh, anyway, it just goes around visiting the right one, and it then animates it, and that's it. Right, I apologise if this has taken an inordinate amount of time, and I'm sure you've already switched off and gone to lie in a darkened room. But you never know, it might have been useful. I will correct that, and let's get on with it.